In today's video, I'm gonna tell you how to configure linear axis in KUKA robot. Linear axis as external axis is commonly used in KUKA robot system. So, before we go to our topics, you have to make sure you have already have these things. The first thing should be you must have the motor data KRC4 or KRC5, which means the motor data PDF menu is very useful for the configuration steps. Okay, you make sure you have this PDF. And in our project, typically if your linear axis is from KUKA official, but the track is customer designed, not KUKA linear, then you have to configure motor parameters. If the track, the linear, is from KUKA and the configuration is very simple. So let's begin with the first scenario. The external linear axis with KUKA linear. How do you configure? How could you configure? And the second should be motor is KUKA and linear, the track is other vendors. So first you double click workvisual. Wait a second. You double click on it. You choose browser. Typically you use workvisual to connect to the current robot to upload the entire system. You must click this option and your browser and the system, the robot will be online. Okay, but in this video I just randomly open a project to demonstrate, but in a real project you can just use the workvisual to connect to the robot and make sure this you have already confirmed and you will find the current online robot system. Let's begin the topic. Okay, we open it. So first we click file. We need to click catalog handling, because we have make sure external kinematics, this option already is in the catalog. If you don't have, if the system workvisual doesn't have this catalog, you choose this icon. Okay, make sure external kinematics in this option. Okay, in this video we already have it. Close it and we activate the system. So we activate the system and we choose add. We choose external kinematics. We choose the system is 8.3, but depends on the real situation. So the first situation is the linear unit is from KUKA. Then it's very simple. You just randomly add it. Okay, you just randomly add it. You just choose the linear unit, then finish. Then you configure position 1 or position 2. Okay, and this is the software limit. Software limit when the reference, right now you can make the random range, and once the reference already set, you can make sure the limit is the accurate one. Okay, because this is the configuration step, the reference, the home position for linear axis, you didn't set it, so make sure tap the random after you set the reference, type the accurate one. Okay. This is for the linear axis from KUKA official. It's very simple. Okay, very simple. You choose position 1 or position 2. Just depends on the situation. You as you can see, just follow your idea. Okay, as you can see, basically we have this function. We have 4 directions for the linear unit. This is the one direction. Another one should be this direction. Sorry, this is the second direction. Go back. Sorry, this is the third. Okay, this is the fourth. So we have the 4 directions for the linear with the linear axis. Get it? And this is the linear from KUKA. So remember, we have 4 directions for the robot. This is the flange. So this is, we can choose position 1 or position 2 means rack. This is the Z-X head robot position. And this is the finish. And once you just choose a reference set, go back to these parameters and you will get. Then you generate the code, download to the teach pendant. Okay, this is for the linear unit from KUKA. What if the motor is from KUKA and the linear unit is other vendors? Then we need step by step. Still, that is the second situation. Second situation is motor is KUKA and the linear unit is different. It's not from KUKA. Okay? Then we have the different configuration steps. We choose add. We choose external kinematics. We choose motor. For example, let's assume we have this one. We choose add. We choose ignore. We have the alarm. We ignore it. And we just delete the first step. We delete it. And we double click it. So, and we close down. Make sure the linear is a linear. Okay, axis tab is linear. Then we close it. And we double click on it. So we already changed the linear. And the first step is negative or positive. Remember, before you set the reference for the linear axis, you type the random number. Make sure as larger as possible. Once the reference already set, go back to these parameters, set the accurate one. Okay? This is very important. So this is the axis, remember? And we're gonna find, for this home position will remain, we don't change it. The second parameters should be the flange, should be these parameters, must be these parameters is very important. These two parameters are very important. And how could you type these parameters? Follow this picture. Follow this picture. Remember, follow this picture. This is the linear. This is the robot. Remember, in the first situation, I told you linear with robot has 4 directions. Okay, 4 directions. A B, C, D directions. This is the flange of robot. So for the A, as you can see, the parameters should be go this. As B should be go this. At C should be go this. At D should be go this. Just depends on the installation the robot on linear unit. Remember, just depends on the robot installation direction on the linear unit. Then you type the correct value on for these two parameters. Let's assume A, okay? We type it. Okay? We type it. And for these parameters, you also can find an answer in this PDF. Motor data, if your system is C5, then you find this C5. Right now, in this video, I just C4. So you have this PDF, motor data. And for example, this motor type, you type the motor type in it. Okay. For example, ME. As you can see, this is the first. You go back to these parameters. Let's enlarge. You will find an answer. This is the controller. This is the driver mode. So under this, okay, you will find these four parameters: position gain, position initial time, velocity gain, velocity initial int time, okay, which is correspondent with these parameters. Remember, find it in the PDF. You can type the number, okay? And once you set this, the next you have to pay attention. We close it and we save the changes. The next step is transmission ratio. Click on it and you will find transmission ratio. Parameters of axis, transmission ratio, motor axis. For these parameters, if you have transmission structure, you type the serial number. And you have to commission on site to make sure this value, this ratio is right. And what is the standards criteria for you to make a judgment to see whether this value is, the setting is right or is correct or not, is wrong. I told you in the ABB before, the best way to do this, you type the serial number. This is the motor distance. This is the how many circles axis rotate. And how do you judge it? I'm telling you. First, go back to the teach pendant. You open the teach pendant. You can choose the display actual position if you have the external position. If you have the external in the teach pendant, once you configure it, you commission on site. You choose you will check axis, the position. You will choose. You will see the real position on this screen, and you can check this screen's number external axis distance compared with the linear track. Compare with the linear track, physically the linear track, how far does the linear track moved? compare with the physical distance. If, let's assume, if the distance is the same, which means this transmission ratio is right. If it's not identical, then you have to change the ratio. I think this is the best commission on site. That is my experiences. If you have more other ways or a better ways to calculate, I don't suggest you just calculate on the theory number. It's not true. You have focus on the real situation. One more time. Go back to the display. Check each axis, particularly actual position. Find external axis position. You move the robot. Once you configure finished, you move the robot and you check this number for the external distance. Compare with the physically, how far the linear track works, moved. Then you will find the answer and adjust this ratio. You get it? That is my suggestion. And this is the transmission ratio set. For the position software limit, this is the transmission ratio, and another parameters should be the position. Wait a second. I think should be the position set parameters, not general parameters. Another position should be general parameters. You have the positioning windows, definition of an axis specific tolerance window. So basically is 0.1. This number is a little bit small, lower. You have to make it a little bit larger so that the system won't cause any alarm. Okay, you get it? This positioning window alarm, just change it. Make sure the system won't cause any alarm. Okay? So after you set this, you just close it. And the next step, you should click Cell Configuration. So we have to map the robot onto the linear unit, because this is the overview of the installation. So we have to, as you can see, we place it, click on it. Okay, then this is the steps we finish, and we have to check the drive configuration. We have to see the drive configuration. We have to make sure the RDC, this topology, is right. If not right, also cause alarm. You get it? You have to check. So after all the steps you finished, you generate the code. Okay, just generate the code, and once generate the code, you can generate. Because right now in the video we have the problems, because we have yes, we don't have it. We have to install it. But in the real situation, you have to install it. Okay, it means the server driver. But for this, we don't use it. In the video, we ignore this. But in the real project, you generate. You go to the catalog. You scan the catalog. you find this. You have to find the driver DTM, okay, and choose to make sure on this option. This is the same. If you don't have it, we have to download the KSP, okay? Because I just randomly, in this video, I just randomly choose external. So after you generate this, go back to the teach pendant. Go back to the teach pendant, log in as a safety maintenance technician. Just log in as safety maintenance technician. And once you log as the safety maintenance technician, you back to the workvisual. Once you generate the code, then you download the code. Okay? Once you download code into a teach pendant, there will have the safety alarm on the teach pendant. I think should be go this alarm. Should be go this alarm. Should be the KSS 15068 this. Then you log in the safety maintenance technician. You already log in. You choose to activate. Then that alarm will be cancelled. And the next step, you should set the reference for the linear axis. Still, log in as an expert. And start up. Master. First, you have to cancel the choose on master. Choose, if you have the external, you choose external on master. Okay, first you have on master. Once you unmaster it, go back, start up, master, reference. Choose that axis, linear axis, and move the axis to the home position, to the reference position, and set it. Okay, then the reference will be set. Once the reference set it, go back to the workvisual, just change the negative and the positive. Okay, remember in these videos, because my workvisual doesn't have the device component, I'm gonna install it. Okay, so ignore this. In the real situation, you make sure you have this it. And if you want to show it, if you want to do it, I'm gonna show you. Okay, just wait a second. I think my laptop gets stuck. Wait a second. Okay, let's go back. My laptop just get a little bit lazy. So remember, once I generate the code, it shows an error, right? Missing device description file for the controller component KUKA Servo Pack 64A KSP. Please execute a DTM catalog scan. So once you encounter or have this problem or alarm, what are you going to do? Remember, it means the DTM catalog means this description file. So we close the current project. You save it. Okay, you save it. You just save it. Basically, this device description file stored in the workvisual software C disk. You can find this software, and basically you can find the software where you store it, and you find it. In my laptop, it stored here program files this place, KUKA workvisual, because this is my workvisual, and you find device description. EtherCAT should be this, and you find KUKA KSP and KPP. You find these files, two files, and you double click on it. Do not open a project. We have to import these two files. Import device description file. We choose that one. You find workvisual. You find KUKA. You find 60. You find device description. You find EtherCAT, this file. You find KSP and KPP. Okay, and XML file. Import. Wait, just import, and it will import. Okay, just wait. Okay, finished. And you go back, open that project. And you activate. And you generate code one more time. You see? No errors, so problem fixed. You can check the DTM. Okay, you can check it. Current. As you can see. So, this is today's video to tell you how to configure linear unit in KUKA robot. So sometimes my video is a little bit naggering. Hopefully you will understand. So if you are master of KUKA robot, still ignore this video. If you are beginners, hopefully helpful and useful. See you next video. Don't forget subscribe my YouTube channel if you are interested. See you.